If you squeeze the entire human existence on Earth into a single day, artificial light has only been around for the last 5 seconds. And in those 5 seconds, even though our world has grown brighter, our connections to the cosmos and nature has faded. Tribute and Light is a commemorative public art installation that debuted 6 months after the tragic events of 9/11/2001. Since then, it has been presented annually on the night of September 11 from dusk to dawn. This powerful display features 2 beams of light projected into the sky, symbolizing the fallen Twin Towers and serving as a tribute to the nearly 3,000 lives lost in the attacks. Over the years, the Tribute and Light has evolved into an iconic symbol of resilience in the face of tragedy. This spectacular display, however, coincides with the peak of nocturnal fall migration for many bird species. Migratory birds rely on topographical cues like coastlines and rivers, as well as astronomical signposts such as the stars, sun, and Earth's magnetic field. Birds often travel at night to conserve energy in cooler and calmer air. When the Tribute and Light was first illuminated in 2002, thousands of nocturnal birds migrating through New York's night sky became disoriented, mistaking the memorial lights for their natural celestial guides. Many birds flew straight into the nearby glass buildings, leading to fatal collisions. Many others exhausted themselves chasing the light cues, eventually dying. To mitigate this impact, a dedicated team of scientists and volunteers monitors the art installation each night of its operation to count the trapped birds. When the number of birds reaches a certain threshold, the lights are turned off for 20 minutes, allowing the birds to escape and continue their migration in dark. This is just one example of how events like these highlight the harmful effects of light pollution on Earth. Before electricity was invented, fire was the only weapon against darkness. Ancient civilizations made use of fire torches, and by 4500 BC, oil lamps were invented. Candles made of wax and tallow were introduced around 3000 BC. Although the light generated from these candles was enough for reading at night, it was too dim to brighten a larger area. Other issues related to high maintenance with wax and oil, like frequent wick trimming and spillage, made these sources of artificial light inefficient for regular use. Society sought something better, and a widely used resource from the late 1700s offered a solution. William Murdoch, a Scottish engineer, invented the gas lamps in 1792. He first implemented the gas lighting system for his own house and then eventually was able to reproduce his discovery to light the outside of his building. It took another 15 years for the gas lamps to be used for street lighting. The first street to be illuminated by gas lamps was Pall Mall in London on June 4, 1807. Despite being a significant improvement over candles, gas lights were not low maintenance. They required manual lighting every evening and needed to be manually extinguished every morning. Additionally, they produced harmful carbon monoxide as a byproduct of combustion. In 1802, the first electric light was invented by Humphrey Davy, but his invention, known as the electric arc lamp, was not fit for commercial use. Towards the end of the 19th century, in 1879, Thomas Edison developed a version of the light bulb fit for commercial use. What makes Edison's contribution to electric lighting so relevant is that he didn't stop with improving the efficiency of the incandescent bulb. He developed a whole ecosystem of inventions that made the use of light bulbs practical. He invented the first power station, then developed the electric distribution system to make electricity accessible to individual houses and commercial buildings. He even invented the electric meter to record the amount of electricity consumed by individual units. Edison's bamboo filament lamps could last up to 14.5 hours. With the invention of the tungsten filament, the efficiency was improved to approximately 1200 hours. But even with 1200 hours of light, incandescent bulbs were extremely inefficient. Out of all the electricity the bulb consumed, only 10% was produced as visible light, while the rest, 90%, was wasted as heat. This meant, even though the light levels were low, the overall energy consumption was very high. The need for a comprehensive set of electrical safety standards became apparent as more cities and states began to adopt electrical power, and in 1897, the first National Electrical Code (NEC) was established, marking a significant milestone in the standardization of electrical safety practices in the United States. The main features in the code highlighted wiring standards, grounding electrical systems, and equipment installation guidelines. As the main source of indoor and outdoor artificial lighting was gas lights during this time, which produced power equivalent to 40 to 60 candles, it is understandable why there was no particular emphasis on lighting levels and their regulations. Following the invention of the incandescent light bulb and its commercialization in the 20th century, nearly all street gas lamps were replaced with electric light bulbs. Although offering cleaner, safer, brighter, and higher illumination, it marked the initial birth of light pollution as they started to obscure the night sky in the urban areas. It wasn't until the 1930s that we hear the first ever documentation of light pollution when the increasing sky glow from the city of Rome made sky observing impossible at the Vatican Observatory. The Pope ordered the relocation of the observatory to Castel Gandolfo, approximately 25 kilometers south of Rome. General Electric introduced the first commercially successful fluorescent lamp to the market at the 1939 New York World's Fair. The inefficiency of the incandescent bulb, powered by other factors like World War II and the need for energy-efficient lighting for war plants, led to the rapid adoption of fluorescent lamps. By the mid-1900s, more light in the US was being produced by fluorescent lamps than by incandescent lamps. Post-World War II, in the 1940s and the 1960s, there was a significant increase in suburban development and infrastructure, leading to widespread installation of street lighting and outdoor lighting fixtures. The environmental movement in the 1970s raised awareness about various forms of pollution, including light pollution. Studies and reports began to highlight the ecological, health, and astronomical impacts of excessive artificial lighting. The oil crisis in 1973 also pushed for the innovation of more efficient fluorescent lamps and led to the evolution of compact fluorescent lamps. The CFLs used about 75% less energy than incandescent lamps and lasted about 10 times longer. In 1986, Arizona enacted the first state-level light pollution law to protect the dark skies for observatories, and in 1988, the International Dark Sky Association was founded. The International Dark Sky Association played a crucial role in raising global awareness and advocating for better lighting practices. The most efficient form of lighting that we know today, the visible light LED, was invented in 1962 by Nick Holonyak at General Electric. It was not until the 1990s the blue LEDs were created by Suji Nakamura. They used about 75% less energy than incandescent bulbs and lasted up to 25 times longer. They also produced very little heat, which makes them safer and more efficient. During the 1800s, about 60% of total energy consumption was dedicated to electrical lighting. Today, it stands at around 20%. Despite the drastic improvements in the efficiency of lighting bulbs in the last century, Global energy consumption for lighting has not decreased significantly. This can be explained by the Jevons paradox. The Jevons paradox states that when something becomes more efficient and cheaper to use, people often end up using it more, which can lead to a higher consumption of the resource than before. So even though the goal was to save resources, the opposite happens. Therefore, as lighting became more efficient and affordable, people found new ways to use it, offsetting potential energy savings. In a world where incidents like the Tribute Light remind us of the challenges, there are also stories that show us proactive measures to combat light pollution. A proposal to construct a Vegas-style sphere in East London was recently denied, primarily citing concerns over light pollution. The decision came after fierce opposition from local residents and environmental groups. The venue's LED exterior was feared to significantly intrude on nearby homes, potentially disrupting residents' sleep and quality of life. Concerns also centered around the sphere's high electricity consumption. While the fate of the project now rests with the higher authorities in the UK, this decision underscores the impact of public voices in affecting change. But the bigger question is, what can we do about light pollution? We can start at home. We can use outdoor lighting responsibly. We can use lights with low glare and direct them downwards to minimize glow. If you're working with a lighting designer on the design of your house, be proactive in approving responsible design solutions. You can ensure that the design minimizes light spill and glare. We can switch to energy efficient lighting. We can replace traditional bulbs with LEDs and other energy efficient alternatives. These not only reduce energy consumption but also emit less light pollution. We can use dimmers, motion sensors, and timers to control lighting and use it only when necessary. Dark Sky International has more than 70 chapters all over the world. You can join the local Dark Sky chapter in your country to collaborate on projects and events. If there isn't a Dark Sky chapter in your community, you can take the initiative to start one. We can gather like-minded individuals and work together to advocate for better lighting practices in your area.